Hey, William.
Hi, good afternoon. Greetings,
My
Tim Hortons.
my lighting is horrible.
Oh, my background noise is horrible. Doesn't matter if I'm in or outside of the restaurant.
You're still at Tim Hortons?
Yeah, I went back to Tim Hortons because we're still out.
Jeez.
So,
Kudos to you for making this work.
well, thank you so much for joining, and very glad that most people didn't have Rogers apparently. Um, I may put you on as the host in case something happens. Last time I dropped off a few times, but it was mostly okay for the call. But I'll put you as host just in case.
Perfect.
And as you can hear, I will also keep my microphone muted.
All right. Well, welcome everybody. My name is Ian McTavish, and I am a mentor with Team 4152. I also have Sam Tops, he's the mentor for our team that's responsible for CAD, and Avalon, who is our student CAD lead for the upcoming year. So I'm going to be using a slideshow as my basis, and I've just posted it in the chat so that if you want to look ahead, by all means. And I am going to share my screen. Oh, I get lots of options here. So let's. All right, so you should be able to see the slideshow. Sorry, I'm just going to admit all. All right, and yeah, you should be able to see the slideshow. If you have questions at any point, I might not be able to see it in chat, so feel free to unmute your mic and just let me know, or post it in the chat, and I'll see if I can have my chat open on my other screen so that I can see it. So if I could actually use the chat right now, and if you haven't used chat in Zoom, you should be able to open up the chat and you can reply to everyone or just to an individual person. But if you can just put a scale of 1 to 10 of where you are with using CAD, 10 being you're a pro and you should be running this session, to 1, you've heard of it and have never really used it, just so I can kind of get an idea of who my audience is. So, perfect. Yeah, and those of you that do have some experience, if you have suggestions throughout, feel free to enter that in. Okay, so I have to start off with our team relies on our sponsors, so I always give a quick shout out to them because we wouldn't exist without them. And the session is going to cover kind of working on designing a robot with a team and using some part libraries and things. Onshape is what we use, and that's what this is based on. And there's a couple key reasons for it. Number one, it is web-based, so it makes it, with COVID, it made it incredibly easy for kids to transition because they could actually use it on a Chromebook when they were stuck at home. And Avalon was actually one of our techno girls. We ran a program and taught CAD that very first year of COVID, which has paid off in spades for our team. And then there's my contact information, so I'll share that at the end as well. And Sam is another great resource. So if you have any questions throughout the upcoming season, by all means, feel free to reach out to us. First thing that I want to mention is that no matter where you're coming at, CAD, it's overwhelming, it's huge, and take some time to think about that and reflect on that, because when we started, we had no CAD skills whatsoever. And our team makes a lot of fun of our very first robot, which was pretty pathetic. But the key thing is that we approached everything with, we're going to learn a little bit every year. And this year it really paid off in spades. You know, we were ranked #2 in North Bay, and so we're team captain for the second ranked alliance. We won our first blue banner, which happened to be at the provincial championships. So it really paid off for us. But it's a long-term process. And a couple strategies that I would highly encourage. Number one, use the kit of parts drivetrain to begin with, and focus on designing mechanisms. Going on to more complex drivetrains, it seems like everybody's kind of like swerve, and we're actually have built a swerve drive, but getting your mechanisms down is key. If you can improve on them, that's your best bang for your buck. Design and build in the off season. So as I mentioned, we've designed a swerve, we've designed a new intake. We're putting those things together this summer. We're testing them, because that will pay off for us in the upcoming year. And if you don't have construction capabilities, get some sponsors. So it's amazing to me how many local millwright companies there are when you start digging around. And a lot of them, if you approach them in the fall, you can say, look, we need sponsorship and we don't want money. We want you to just cut out some parts for us. It's amazing what you can get. The other thing is that we use construction companies. And so my son's company is one of our sponsors. And so when we're designing the game playing pieces, you know, we made the hub and the hanger, those kinds of things. Getting a construction company to sponsor works really well. So they cover the cost of all the materials, which is a couple $1,000s. They help with building it, and it's so crucial to have those kinds of things. Like with the hanger, until you can actually hang the robot, you're not 100% sure if it's going to work. So you want to make sure that you are able to try that. The other thing is that, again, if you don't have the capabilities, there's cheap alternatives. So there's the cheap CNC, which is basically just use a printer, print off a sheet of paper with the markings on it, glue it to a piece of material. Now you have an incredibly accurate system for figuring out where to put your holes and things. So there's ways to do it. We 3D print jigs. The key thing that we found is don't use the jigs for drilling. We use a punch so that we put the punch in the hole, hammer it in, and it allows us to easily transfer what we want to, where we want our holes drilled. And the other thing is raw materials. So talk to stores if they have any barriers. A lot of it is polycarbonate, which is great to work on. We got a ton of supplies from a local company that made barriers for stores. So there's some strategies that you can use to really develop your design skills. In Onshape, Onshape has some training stuff, and fundamentals is one of the learning pathways. And this is kind of our requirement, is that you have to work through the fundamentals. Anybody on our CAD team, that's a job that in the fall they start. And I also teach tech design at the high school. So what I have, that's part of my course. You got a 10% automatically if you work through the fundamentals and complete them. The biggest problem that I've run into, and I'm just going to switch to, so here's Onshape right here. There's the Learning Center. That's what I'm referring to. And I'm just going to open this up. So here is the fundamentals and everything, and there's the learning pathway. And how it works is that if you click on the course, you have a whole series of different little mini videos, and you play the video, and then you click on the next lesson and play it. And then eventually you'll get to an exercise, and in the exercise, it's step-by-step directions, do this, do this, do this. The problem that I found is kids watch the videos, and they just kind of like put them on in the background and don't really pay attention. And so I really emphasize that you have to be an active learner. When you watch the video, you should be following along and doing it. And the other thing is that you work through the exercises, because I'll have students, they'll be like, oh, I'm done. And it's like, okay, design this for me. Oh, I don't know how to do that. Well, you didn't actually do the exercises then. So even if you're not 100% comfortable, I highly recommend work through all of the Onshape fundamentals. There's a ton of stuff. There's also other fundamentals for feature scripts, for assemblies. Somebody mentioned that in the chat. And those are so valuable. And just gonna, sorry, I'm in the wrong spot here. Yeah, if you work through the assemblies, that's in the fundamentals, and it's hard work, but it pays off. So that's kind of a key thing to spend your time doing. Okay, so designing with the team, there's a lot of different factors in here. Oh, Peter just mentioned having extra monitors so that they can work on one screen, watch on another. That's excellent. And I would check our school. There's a ton of monitors kicking around because everybody's transitioned to Chromebooks and stuff. So I've set up dual screens as well, and it's really worthwhile. Okay, getting back. So starting with the spreadsheet. So with this entire plan, when we're designing on a team, it's really important that everybody knows where things are at and everything. So we always start with the spreadsheet. We use Google Sheets, share that, which is really useful. If you don't have access to Google, Microsoft has the same kind of thing, but having something that's online that somebody can check at home, somebody can check, multiple people can open it up, it makes a world of difference. And what we do is we lay out a plan. So we have different documents. So our first document is our full robot. And the key thing is that our full robot should only be touched by the CAD student lead and the CAD mentor. And then other people can view it so that they can get an idea of where things are, but they shouldn't be editing the full robot. And that is then there's subsystems. So the drivetrain is always our first subsystem because you need to be able to drive around. And you'll notice that we've got a system numbering for, I'll go over that in a few minutes, but basically you can start this at the beginning of this very quickly because there's always some commonalities. So for example, you have the drivetrain. Every year, since First Robotics started, you have to be able to have your robot drive around the field. So the drivetrain's part of it. This year, there was the game piece, the cargo. So right off the bat, I know I'm going to need an intake to be able to pick that cargo up. I'm going to need some way to store it, and I'm going to need some way to deliver it or shoot it or whatever. And some years, so deep space, for example, we had the hatch mechanism. Some years that mechanism does all three things. Other years, like this year, we had 3 separate subsystems. So you know that you need to do that. The question becomes, can we do this with one subsystem or do we need multiple subsystems? And ideally, you want as few as possible, but the moment you're involving multiple, like this year, you could store 2 cargo. Well, you probably are going to need a way to store them, and you're going to need a way to shoot them. So some of these things right off the bat, the hanger, that's the climber. And then you have other things like electronics and stuff. And this year we added something new for us, a superstructure. We're inspired by some other teams out there that do an amazing job. And the superstructure was something that Sam had researched with some other teams. And it was like, this is a really good idea. And really happy with it because it allowed our design to be much more modular. So this is our spreadsheet. that we would kind of use. And the other thing is that we've got color formatting and stuff. And I'm just going to quickly go over some of that. So sheets. So if I'm setting up a new spreadsheet, and I know that this isn't CAD, but this organization really pays off with the team part of it. So you have your part number, item, status, and when you do a part number, we break it up. So it always starts with our team number. And so with my class, I have students use their initials for their starting thing. And then we have 2 digits that represent the project. So for off season, it might be SW for an off season swerve. But anytime it's a competition season, it's always the year of the competition. So 2022, 22 is the thing, then an assembly, and then a 2-digit number. And if I click on it and just drag down, it automatically recognizes the pattern. So that makes it really easy for me to lay them out. And then I can go into and just name them. And you might want to just start off with, okay, I know I need the full robot, I need the drivetrain. And then you can have your status. So let's say I'm going to have a status of in progress. Well, when you highlight a section, you've got conditional formatting. And this is really useful, is that I can set it up to be a formula. And I can go, okay, equals $C, because I want the C column 1. And what I'm going to do is, if that equals in progress. And if that's the case, I'm going to highlight it yellow. Done. So just like that, I can have, as I type things, so if I have something else that started up, I type it, it automatically color codes it. It seems like such a simple thing, but I find it really helps as you get really busy, because you can start going, okay, this is white, we haven't done anything with it, we got to address it and start figuring that out. So coming up with kind of a plan, and this is going through the rules and looking at how do you score points and what are the things that you're going to include. And sometimes you'll have, oh, we're going to include this, and you decide later on that's going to be too complex and you're not going to use pneumatics, then you just delete it, cross it out. So it's really easy to do this early on and just have your basic concepts. And then if you go, so when we did deep space for our shooter, I was really set on being able to have a traditional shooter. And Sam was the one that convinced me that that's not the best strategy. If our intake shoots it as well, just like that makes it more logical, because the target was so small, and that really paid off. So we didn't need these extra subsystems, but that's okay. I've already mentioned the naming. So team number, what the project is, the letter A if it's an assembly, and P for it's a part. So if you're new to CAD, in Onshape, you're kind of got 2 different things. So a part is one individual part. So I might have a piece of metal with holes in it. An assembly is where I've taken that part and I've attached it to another piece of metal, and I've got some nuts and bolts that secure it together. So the letter indicates what kind of thing it is, and then we have our number. And so in my assembly, so in my drivetrain, I might have a whole bunch of different parts. So then I have a 2-digit number after all of that. So I can tell that this is from the drivetrain, and then this is a unique item in the drivetrain. And when we're manufacturing, we'll often use those last 4 digits to be able to keep track of our different parts and everything. And then we'll have a bin that everything for the drivetrain goes into that one bin. Just putting it out there. Any questions so far? Feel free to put anything up in the the chat. Okay. Ensuring IDs are unique, that's really crucial to transition from your design to your assembly. And you have to make sure they're unique. We used to kind of do it as we went, and I found it's easier to do it with the bill of materials. And so I'll be demonstrating that in a bit. Okay, teams and projects. I've shared access with you. We have the Enterprise Edition of Onshape, and I love having it. I don't know if I can afford it. I managed to talk them down. Their initial price was $4,000, which was ridiculous. And William, I'm going to throw this out to First Robotics Canada. We need to get Onshape on as a sponsor to provide Enterprise Edition for teams. We got to figure out how to make that happen because it is so worthwhile. And they do have a free version. So if you're an educator or student, you have a free version. So I highly encourage you to take advantage of that. But I would contact them and say, I'm interested in the enterprise. We're a First Robotics team. And when you find out the price, tell them, I think my initial quote was $5,000 and I just said, I can't afford it. That's too much money. And so I explained to them my budget with my school and what it was, and I talked them down to $800. I don't know if I'll get that again. It's coming due, so I got to find out what they're going to charge me. But in Onshape, you have some options, and you'll see a few different things because I'm in the enterprise version. But one of the key things is that you can structure Onshape. You can structure teams and you can structure projects, and these are two different things and really, really useful. So just going to show you. So here is our team 4152, and this is our project. So the key thing is with the team, I can have different people on the team, and I can assign them in the enterprise. I can assign them different roles, which is really useful. I think you can do that in the free version as well, but I have to check. It's been a while since I've used that. But the bonus is CAD designers have the ability to obviously modify things, but I can assign view privileges to other people. So if somebody's assembling a mechanism and they don't do CAD at all, I want to give them view access so they can see how it goes together. They can hide parts, they can see what fits where, but they don't have to stress about damaging the design. So that's a really useful to be able to differentiate that. So I'm just going to kind of show you, these are all the documents for this past year. And there's our full robot and then all of our different subsystems. And the numbering system is really useful because they're all in order based on the spreadsheet because it's all alphabetical. But then I have the name so that I don't have to remember which one's the electronics. I can just read, that's the electronics, and I can open that up and be able to access it really easily. So I also have some other things that aren't the robot. So we did some ideas at the beginning, and as we prototyped and stuff, that's where we kind of kept all of those ideas. And as we kind of finalized, yep, we're going to have a storage system, then we started doing our prototyping for the storage in that particular one. But the ideas thing was really useful. They also provide an entire field, which is incredibly useful because then you can see how will things fit. If you're going under the hanger, will your robot actually fit underneath and stuff? So that's kind of handy. And just going to quickly show you our robot and then kind of go over how we did it. So this is our robot this year. If you remember January, we were in lockdown. So we couldn't get together, which made it difficult. So we made a couple design decisions. Number one, we've been sticking with the kit of parts for many years. It's a fantastic design. It works. And as I mentioned before, we've been really focusing on putting our time into developing other mechanisms. We've still designed custom drivetrains, but we just haven't focused on using them in competition. until we see a huge advantage. And now that we can afford swerve, we're going to be hopefully introducing that at some point. But there's the complete robot. Just a quick overview. Don't have the bumpers in here, but here's the cargo. And basically, I think our intake is hidden in here.
Hang on, Ian, I'm messing with stuff.
Sam's messing with stuff. So we have an intake that will suck in the cargo. Our storage mechanism is basically, there's nothing motorized with the storage mechanism. What happens with it is that it's just gravity. There's a slight slope to this polycarbonate, and we have some barriers so that the ball can't bounce out, and it just will roll into these wheels, and those wheels will hold it in place. We have a little color sensor. I don't know if you can see it right there, but that way we can determine what color the ball is. And if it's the wrong color ball, we can just spit it out. So there's a couple of options. And basically when we're ready to shoot, our storage system will spin up and those wheels will push it. We have a turret up here. I'm just going to change my angle here. So this turret, that's just the Armabot turret. And again, as you're developing in terms of design, it's well worth spending the time. Like the infinite recharge, we decided a turret would really help us strategically. And I approached a connection and said, look, here, we need some help. This is what we want to be able to do this. It costs this much money. Could you help us out? And that person paid for it. If you have trouble getting sponsors, having really specific things like that make a world of difference. And the turret we've been able to use for 2 separate competitions, it's really paid off for us. It just gives us another layer of capability that we didn't have. And we're at a stage now where we could design and build our own, but that, if you've ever watched any of Karthik's strategy workshops, that you have a finite set of resources, time, money, and skills. And, if we're going to design and build a turret, that's going to take a whole bunch of resources. And that means other things are not going to be as well developed. So we need to pick and choose. So here's our shooting mechanism. So we've got 2 wheels, which helped reduce the bounce. And a lot of our design decisions are based on research and based on prototyping. So it's really important that your strategy drives what your design is, and then your prototyping allows you to fine tune it. And that's how we shoot the cargo. At the hangar, we have these climbers. We're using the telescoping climbers. Sam worked with students to design these, and it basically we used ideas from ThriftyBot. They had a really good climber, and we used the CAD from theirs to have a look at how they structured it, and then use that to guide our design. And these are our pterodactyl hooks. So basically this telescoping climber shoots up, pulls us up, and then these hooks are just used surgical tubing. So they will just slide, the hanger will slide, they'll push back, and then when the hanger's underneath it, they snap back based on the surgical tubing and lock in, and then our climber can climb up and angle out with the pneumatics. So that's how our robot basically works. There's our intake. So we have the bar at the front, we have the crash bar. After our North Bay competition, we realized that a 16th inch aluminum is not strong enough for that particular design. So if you're going to do that, you either make it really solid so that when you get nailed, it's not going to buckle, or you make it so that the intake will automatically fold out of the way. So we're designing a new intake to test that concept so that we can improve. This year we had more damage, but that's partly because we went farther than we've ever gone, and it just took a lot of wear and tear. So that's the overall design with that particular robot. And we're gonna, with the project, it's really handy because you can structure it and add different documents and things. So this is one of the first jobs for our CAD leads, is to set up the structure, and it's actually not hard. So I'm just going to jump. Sorry, I just got to find my right. Okay, so in my documents in Teams, I've got a summer mentor, which I've shared, all of you have access. And we have, so I've already set up a few of the things, but it's as simple as doing this, is just creating a document and then referring to the spreadsheet, which of course I didn't. Just gonna quickly, so that's the bumpers, or no, gearboxes or electronics. Okay, so I'll just pick electronics. And just like that, that document's now part of the project. It's there. So it's really simple to add things like that. And you can see it's in there. So that's the first part. The other thing is that we're going to go into the drivetrain, and I'm going to go over, while we're waiting for that, just get to the right screen. Resources. So the drivetrain, I can design a kit of parts drivetrain in under 5 minutes. Swerve drive, a little bit longer. And it's not because I'm excellent at CAD, it's because there's a ton of resources out there. So one of the resources, and I'll just show you how this works. So we're going to just create a new assembly, and we'll create a new version of the drivetrain to show you how it's done. So some of this stuff, if you're new to Onshape, then I'm gonna highlight some of this, and those of you that are experienced, just bear with me. But the little plus sign at the bottom of the screen, that allows me to easily select. And in this case, I'm creating a new assembly, and there's my new assembly. So I can create part studios and things like that. Applications are really handy. And if you go to the App Store, the one application that we use a lot is called MKCAD. And if you're in the applications, MKCAD, now here's a trick for those of you that go for the enterprise version. The enterprise version, whoever controls the enterprise version, which in our case is me, can enable or disable apps or specific apps or things like that. So you want to make sure that you go through the settings, because if it's like it's not available, that's why. So MKCAD, this is the library, and basically this is the first robotics team that has worked on creating models for all kinds of things, and it's phenomenal. So when you click it, you just click install, it's free. And when you do that, you end up getting this little MKCAD inserter in there. So I'm in the assembly, there's the inserter. When I click it, the first time you load it up, it'll just show favorites because it takes a moment to load everything in the background. So just be patient with it. And then there's the kit of parts chassis. So I can just go, what's my length going to be? What's my width? What motors are we using? So if I want Neos, and then I can go, if I want wheels or battery mount or whatever, and I can click insert, and just like that, that's going to be popped in there. So MKCAD, if you look through, they have a ton of different options. So gears, gearboxes, there's the entire playing field. really, really useful. So there is my kit of part chassis. What I always do is I always fix the item, and my only beef with this, which I might put in a request, is there's the origin right there, and my kit of parts chassis is obviously not centered on it. So what I will frequently do is just simply take the origin and a point, and I'll look at the measurement tool and I'll figure out how far apart they are and how wide. And when I do that, I'll then, I need to obviously unfix it, but I can then select it and select this arrow and set the distance and get it perfectly centered. And the reason I like it perfectly centered is because then you can have your center of gravity. And with your design, quick question, did anybody compete this past year and use the EveryBot? So just put a Y if you use the EveryBot this past year. The EveryBot design is phenomenal. They do a great job with it. And what I found is that there were a number of teams that integrated parts of the EveryBot. So for example, the climber, but they didn't use the full design, and they ran into troubles with the climber. And the reason is that the design is so dependent on the center of gravity of your robot. And if you are using different mechanisms, your center of gravity is going to be different. So the climber might not work based on that. So those are things that you don't think about. And so when you're setting up, if you can position it so that it's directly on, so that way you can check your center of gravity and know if things are working on stuff. Anyways, there is my drivetrain done. So it can just be as simple as that. And I keep emphasizing, as you're developing using CAD within your program, it's a give and take thing. You want to make sure that you're not taking on too much. So if you can use things like the kit of parts that allow you to have a very sturdy, solid drivetrain to begin with, it makes it a lot easier. And because once you develop those mechanisms and you find what your failure points are, it makes it so much easier to get better as a team. So there's MKCAD. That's how you add it. And the Milken Knights, team 1836, they're the team that originally developed this, and just a huge thank you to them. It's amazing. Now, in terms of documents, you can see I'm referring to step files. And step files are a format that you can use to share 3D models with different things. And if you've ever done 3D printing, you may have encountered STL files. So STL files, stereolithography, those are files that are great for sharing 3D printing. The problem is that you can't really edit them very well, whereas a step file is an actual 3D model. So a couple things. First Robotics, for example, when you go into the game, so programs, game and season, there's a whole bunch of links. And again, I highly recommend spend the time now exploring this past year so that you get comfortable with where things found and stuff. But they have computer-aided design models and they have on-shape models. So it's a quick, easy way to access that. And getting the playing field, it might seem silly, but it's really, really useful because then you can actually get, one of the things that we do is that we just use the measuring tool in Onshape and work out, okay, this point is this far away and stuff. And so we can tape off our playing field so it's easy to find where things go. So that's really useful. Vex, AndyMark, Rev Robotics, those are the big three basically. So if you go to Vex Pro, and if you're buying VersaFrame stock or something, and again, we use our CNC router to make our square tubing, but I'm thinking this upcoming year, I'm thinking of investing in some Versa stock, and it's simply to reduce our manufacturing time, and it's so that we can allocate that resource somewhere else. So it's balancing those things. And there you have CAD files right there. Now this is available in MKCAD, so you don't need to download it, but being able to download it, you can see it downloads a step file. And then if I'm going to use that step file, I can, whoops, the plus sign, I can import, and I can, that will import that into this particular document, and then I can access it. So it's really useful to do that. And most of the time that works incredibly well. The reason I say most of the time, there are some companies that don't share the specific, the measurements might be slightly off, and they do that on purpose because they don't want people to duplicate. Thankfully, most FRC suppliers want you to be able to accurately use it, so it makes it a lot easier. So there's that. Sorry, I just got to get back to my slideshow. So Vex, Andy Mark, Rev Robotics, West Coast Products. One of the reasons I mentioned West Coast Products is they have a couple things like the Gray T elevator. So it's a really good way to import their elevator and just look at how is it designed? How does it work? So that's really useful. Mcmaster Car. I love Mcmaster Car. If something exists, you can probably find it here. So for example, retaining rings. We use E-clips quite frequently, but we also use this style of retaining ring and push-on rings that are used on sim motors to secure gears and stuff. And basically, if you find one that you're gonna use, you've got all the different measurements and stuff. So that's going to be, and go to the product detail, and you have your drawing. You also have your step file that you can download. So it makes it really useful to be able to access. Even if you're not buying it, just having that access is really handy. Sorry, I'm just trying to, if somebody had a question, I thought I heard something, but I'm not sure if that was at my house or not. Spectrum. I'm not necessarily getting parts from Spectrum, but the reason I'm sharing this is Spectrum 3847. This team has put together this group of resources, and basically you pick a year, and they have CAD models of different robots. Teams submit them, and then you also have technical binders, and this is just a fantastic resource to learn. So 1678, for example, there's the CAD for their entire robot. So I can see how teams design their robots and how they are together. And some of the teams like 1114, these are teams that are consistently top of the game. Fantastic. There's 4152 right there. So really good. And the thing is, most are nowadays GrabCAD, and so there's the GrabCAD. I can load this up, and with the 3D model, I can hide elements. I can see what the elements are. It's really powerful. So learning, if you go, okay, 2023, let's say the game piece is a rectangular prism, and you're going like, oh, geez, I know how to pick up a ball. How do I do this? Well, go to this and look at different first power up and recycle rush. Those seasons we dealt with rectangles. So you can see how they designed things to pick up those, makes it really worthwhile. Fastenal. Fastenal is where we get all our nuts and bolts from and stuff. And with design, really focusing on standardizing. So we use 1032 socket head for most of our stuff. And if something needs to be smooth or flush, then either a button head or a flat one, but we stick with those things, and you get all your different measurements, and really useful. Other design tools that I'm just going to mention, JVN. Peter just has a question, does Fastenal? Yes, I approached Fastenal about sponsoring our team, and what they said was they would just give us a discount. And there are times where I go in and I'm like, you're only charging me this much? It's amazing. So highly encourage you to contact your local Fastenal, and just go in and say, this is what we do. Would you consider sponsoring us? And we don't want any money from you. What we would like is either free or discount, and see what they can provide you, because it's well worth it for you. Okay, back to design tools. So JVN, this is a design calculator. And the biggest thing is let's say you're going to create, this past year, you had to create an elevator to pull your robot up. This calculator allows you to put in, my robot's going to weigh this much, it's going to, and look at different gear ratios, and it will tell you not only whether it can do it or not, but how quickly it can do it, and everything. And you can see the little spreadsheet here. You fill in anything in pink, you fill in. So for example, the total robot weight, well, there's always a weight limit in the rules, and there's a weight limit for the bumpers and the batteries. So we just add those together, and there we have what maximum weight, and we always deal with the maximum, and then your gear ratios and stuff. I'm not going to go over that right now, because I share that later. Belt calculator, if you're using belts and pulleys, West Coast Products has an amazing belt calculator, so you can get the center to center distances. And I'm also putting up Techno Girls. This is I mentioned when COVID hit, this is a series of tutorials that I created on designing a little mini bot, but it's using Onshape and it's using CAD, and not to toot my own horn, but I think it's pretty good. But it covers a lot of the concepts of, we do this and here's why we do it this way and stuff. I'm working on a new version because there's some techniques that I now know that will make it even easier, but that's good. Feature scripts. These feature scripts, so we have a laser cutter, and I highly encourage you. So if you have a company in town that does promotional clothing and things like that, contact them, because I bet you they probably have a laser cutter. And I found out that's to be the case. And laser cutting is fantastic for prototyping. So that's the kind of thing to approach them about sponsorship and go, in the fall, we'd like to do some tests with you. And then in January, we're going to need a couple things cut. And that's an easy sponsorship. You don't want money from them. You want access to their machine. And the beauty with Onshape is you can share the file and they can cut it, and it's just a matter of picking it up or getting it dropped off. So laser joint is a way that if you want to join two pieces of wood at 90 degrees, you can cut out things. And I mentioned, like, with designing something like that's incredibly hard. With this feature script, you're just designing, here's my base, here's my side, and in probably 2 or 3 minutes, you can have all the laser joints done because of the feature script. The other thing which has driven me nuts for years is laying out pieces. So let's say I've got a bunch of pieces and I want to put them on the bed of a CNC or a laser cutter. Manually doing it is incredibly time consuming. Auto layout, it does it for you. And man, that makes a lot of difference. Julia's feature scripts, there's a ton of ones, extrude individual tube converter, adding belts and things. And I'm just going to show, I'm not going to show these videos because you can watch them on your own time, but I'll post the link so that you have access to that. And so the link is in the chat. So these are just some videos that I've thrown together on how to do these different things. So I mentioned Mcmaster. So the step-by-step on how to export something from Mcmaster, how to import it, creating belts and pulleys, square tubing and fasteners. And most of these are fairly short. The gearbox is 17 minutes. It's a long one. I don't know how to do gearboxes quickly. It's just a time-consuming concept. But some of the other ones, 5 minutes, 3 minutes, really complex stuff that's really, really useful. So I'll go over some of those things, but take advantage of that. So I've mentioned the drivetrain. We've already assembled that. That's fantastic. Couple things that I do want to mention is you need to make some decisions very early on. And the drivetrain is always like the first decision. How are you going to get from point A to point B on the playing field? And to me, it's almost like I'm thinking of a flow chart with kind of like, okay, is it a flat field? Yes or no? If it's, are there choke points? All of these different things, your strategy has to drive your design. So the kit of parts chassis, we've used that for quite a few years. And what we try to do is we try to stick with the same dimensions each year. And that makes it really easy because then we can use a previous robot to prototype with. So that makes our life a lot easier. Having said that, there can be times where it's strategically advantageous to do something totally different. But you have to think about your own design skills and manufacturing skills. And that's why developing in the off season is so crucial, because you'll know whether you can pull it off or not. The kit of parts is really good. Having said that, like we broke wheels this year, but we were very aggressive with our driving. So that's why. The other thing is you need to think about, you're going to have an autonomous routine. So at the bare minimum, you want to have your robot drive a set distance. Now you can do that with time. So if you're going to stick to sim motors, do that with time. But if you're going to be like, we want to be able to move here and here, that's where encoders get really powerful and really useful. And if you don't know what an encoder is, it basically tracks rotation of a wheel. So Neo motors and Falcon motors have encoders built in. So if you're going to use the kit of parts and you're going to stick with sim motors, then you would need to buy a separate encoder to be able to take advantage of that. And with that, then you need to figure out how do you mount it, how do you wire it up, and all of that. So there are times where you look at the pricing and go, a sim motor is really cheap and a Falcon motor is really expensive. But once you add up all the different elements of, I get this much power, I have a built-in motor controller, I have an encoder, dollar-wise, there's not a huge difference. So now's the time to start fundraising. So in the fall, this is when you start pounding on doors. And if you go, like when we approached Seals for Life, that was one of our things, is that we wanted to transition to brushless. We wanted to be able to test out Swerve. And so they put $2,000 down for Swerve, and Kimberly Clark put another $2,000. And that's how we got 8 Falcon motors and Swerve modules. So, but you got to be strategic. So again, drivetrain design, there's basically 3 standard options: kit of parts, a West Coast drive, or Swerve. So make the choice. I highly recommend you stick with that, and then in the off season play with these. And when you get to a point where you're going, we can do this, and then you transition. I've already gone over how to insert it. Planning your subsystems. So integration is key. So this year, this is our intake. Shout out to Avalon, who designed our intake system. So that's what brings the balls in. Then they're into our storage system, and then our mechanism, our shooter, we have a camera for auto targeting, and that allows us to do our shooting. And if you've never used a camera, now's the time to explore. Limelights are really expensive. We went to a local camera store and said, would you sponsor us? Because this fits what you do. They don't stock Limelights, but they agreed to buy a Limelight for us. So it's finding companies that match what you're trying to do. And the Limelight allows us to auto aim. So basically you're eliminating if the driver's shooting, you know, if they're a good shot, they might get 40 to 50% of the shots in, whereas the Limelight, we're able to get 80 to 100% of the shots in. So it makes a huge difference. So that's our path. And that's the thing, is that even though each subsystem's their own, we have to think about where do these go so that they feed into each other. Okay, so Crayola Cad, I'm going to show you some Crayola Cad right now. So getting back to our drivetrain. So here's our drivetrain. And basically, as I'm working this out, what I want to do is I want to be able to figure out where are the bumpers going to mount to. So this is, and Sam's just mentioning Photon Vision. It uses a Raspberry Pi. We've been playing with that, and it's looking really promising, but it is a bit more work. Okay, so here is, I can see I've got my bumper mount, and that kind of constrains where things go. I'm also going to have my intake. Where's that going to mount? All of these things. So what I'm going to do is I'm going to create a part in context. And this button right here, Create Part Studio in Context, it's really, really useful. I'm going to select an origin. And what I'm going to do is click OK. And what this does is it creates a new part studio, but I can see where things go based on this. So I'm just going to take this right here and I'm going to sketch. And what it does is that now I can refer to the geometry on here. So if I go, okay, I'm going to click this use command. And what I'm going to do is those bolts are not available. So I'm going to pick that bolt and that bolt and that bolt. And that bolt. And I'm going to use,
Ian,
yes, Sam.
I'll just mention, so you might not realize what the use tool is doing there, but it's pulling the geometry from something else. So there's a circle in another model. So when I click that, or when he clicks that circle, it's making an exact copy of the circle in the model you're working in.
And that's where it's so useful. So if you haven't done creating a part, this is going to be very complex, but all I'm doing is I'm creating a bunch of lines, and you'll notice that I've got little icons on the screen. That line shows up in orange. And so those are constraints. So that constraint tells me that this line is going to be a vertical line. And the other constraint is it's coincident, which means it's touching that line. So, and then there's my dimension tool. And I can specify how far apart these things are. I'm just going to go 1/4 of an inch. Now, what I've got here is I have a sketch with 4 holes and 4 lines, so it's a rectangle with holes in it. I can automatically switch to extrude, and that extrude, unfortunately, I must have a closed shape, so I'll just click there. There we go. So this right here is obviously not what I want, but I'm just going to lock it in. I'm just going to make it some obvious color so that this is Avalon. Can you quickly come down and let Clem out for me, please? Sorry, I've got my dog with me and he's getting antsy right now. Okay, so this is a bumper mount, and what I would do is I would obviously put the other bumper mounts in there, but I'm keeping things simple just time-wise so that we can get as much done as possible. So I can insert that. And the nice thing is that it's in position where I want it. What I'm going to do is I'm just going to move it up. And the reason I'm going to move it up is I am going to, that allows me to fasten it. So that's the fasten mate. And I can click that circle and I'm right click. So right click rotates. That allows me to rotate, and then holding the scroll wheel allows me to pan. And this is going to be the fasten mate. I want you to look at that. You'll notice that there's a blue, green, and red line. So if you've ever used SolidWorks, for example, SolidWorks is another CAD program, and basically you would create two mates to fasten it. Onshape uses one, which is kind of counterintuitive for anybody that's been using SolidWorks, but basically the orientation of those red, blue, and green lines determine how they line up with each other. I'll just, if I clicked it the wrong way, you can see it flips it the wrong way. So just like that, I now have that locked in. Now, I can now take this and I'll go, okay, what I'm going to do is I am going to right click this part and I'm going to create a new sub-assembly from this. And I'm not seeing that. Give me 1 second. Okay, so move to new subassembly. So this is now part of a new subassembly. And if I look at my tab manager, these are all the different things in this particular thing. And there's my subassembly. And I'm just going to fix that. So I can now rename this, and 4152 SMA01-01 is what I set up in the subs for my bumpers. Basically, I always associate bumpers are part of the drivetrain, so they're kind of a subassembly of the drivetrain. So that's the part. Where this gets really handy is that I can now right click this and I can move to another document. And if I've already gone through and created the document, I can just select it. I haven't for my bumpers, so I'm just going to create it. I'm going to create it right now.
Now, Ian,
Yes.
I can't remember, is where you're moving it to a separate document right now, was that an enterprise only feature?
I think you can do that in the regular version. So I'm pretty sure you can do it in the regular. It's definitely a huge feature. For that reason alone, it's worth money to me to buy the enterprise if it's not. Sam, do you mind looking up to see if there's a chart with what's involved in both? Anyways, going back to our project, you can see that document is now there. Any one of you can open it up and be able to access it. So obviously, I'm going to replace this. And what I'll do is, again, use CAD, and I'm sure there is a bumper. Okay, so here's a part. No, I didn't want that in CAD. Let's undo that. I wanted it in the assembly. There we go. So this is a triangular bracket, AM Andy Mark. So this is an Andy Mark, and you'll notice that I'm using the arrows here, but I can type it in and get it exactly where I want it. And if I want to mate, I want to mate that particular part with that hole. That will line things up. This part's not great for what I'm doing, but it's showing you how to do it is my purpose. So I have this. You can see the holes are offset. They're not the same, which is so annoying, but that's okay. Okay. I'm going to fix that part. And what I'm going to do is I'm going to delete that bumper. Now, in my drivetrain, I have that. And I've made some significant changes to this. Not really that huge, but it is. So what I'm going to do is I'm going to create a version. Andy Mark bracket. So I bought this Andy Mark bracket. So this version is my new version. And that assembly is in there. And if I go into my drivetrain, you'll notice that beside that assembly, there's this little circle. If I click that circle, it tells me that this is not the latest part. And this is so incredibly powerful. What I can do is I can mess around in that and make all kinds of changes, but it doesn't change this assembly until I tell it to. So that's really, really useful, because if we decide, oh, we went down the wrong road and I'm not happy with that, we can fix that. So I can go, yep, we're going to make that change, update. And just like that, that is in the exact same position that it was. You can see this bracket's not a great choice because it overlaps. So I don't want to do that, but it gives you the concept of what you need to do to be able to put in a part and stuff like that. It obviously does change this fasten mate. And that fasten mate, the original part doesn't exist anymore. So I can X that. And then I can just zoom in and get the new part. Oops. I don't know if I did that right, but there we go. So now I've got a new part. I've got my bumper. I can modify the bumper in there, but I can also create, and I can do all of those changes. So that's really, really useful for that. I'm going to jump out of this particular document and go into my full robot. And just if you can just put a Y or something in the chat if you're still awake. I know that this is a long, late on a Friday. I don't know if, okay, we've got a few people still awake. That's awesome. I don't know if Peter's awake or not. He's got a smiley face there. So while this is loading, okay, I got too many things open. So let's close a few things. I'll close that full robot. That will speed up things. While this is opening, I'm going to just highlight something. So the biggest challenge we had was students really nervous about breaking things. So that became a bit of an issue, and I'm not sure why my screen is. I seem to have been kicked out for a second there. Okay, so as I mentioned, students were really nervous about breaking things, and this is what's really useful is over on the left here, you have versioning. And versioning in history is really useful because you can go in and you can look at parts based on a certain point of time. So here's all the changes. So there were 29 changes on July 1st for this. And I can actually open that up and I can see what everything looked like at that particular point. And oh my gosh, everything is not. I'm going to close that one up. So that's incredibly powerful because then I can restore. If you've ever used GitHub for programming, it's the same idea. You can take that version and restore it. And I am not sure why that's not loading. So the versioning in history is really, really useful. Anyways, getting back to Crayola Cad, this is kind of just an example of what it might. This was actually our robot this year. Early on, we're like, okay, we're going to need to mount things here. Our intake's going to be there. Climbers. We ended up changing where things mounted, but it allowed us to kind of plan if the bumpers are here, where can things go so that everything will fit. And we've always run into problems with people not bothering to deal with the bumpers. So we try to put bumpers in as one of our first things, just so let's lock it in and it becomes a design constraint. You have to work around it. So I've already gone over some of this stuff, how to create a part in context, how to use the use. So for the intake, for example, we kind of blocked off like we're going to need to mount it somewhere. Where are we going to mount it? And distances and stuff, and then moving it to its own document. Now, comments are really useful. I really like the enterprise version with this because then I can assign tasks to people. And that basically over on the left, you have this comment icon. And if you type the @ symbol in the person's email address or their name, it pops. And what you can do is you can actually tag the part. You can take a screenshot where you can, put an arrow. I want you to add a a part here, all kinds of stuff. And you can obviously add text and you can assign it. And they get an email going, you've been assigned a task. Makes it really, really useful. So sorry that this is freezing up. I'm not sure what's going on here. I'll blame Rogers. The other key thing is follow mode. And Sam.
Hello.
If you could open up the full robot, I'm going to get you to do something, and I'm going to go into follow mode so that I can show people what follow mode looks like. So I'm just.
My assembly opens up a lot faster than yours.
Yeah, you've got a faster computer than mine. I'm not sure why mine is freezing up like this. I might just close Onshape and go back in. Earlier last week, I had received a question about the difference between enterprise and just the free education version. And there's a couple different differences, obviously, but one of the things with the enterprise is that I can add users. So I just export the email addresses from our student information system for my classes, and for the robotics team, I have a Google form, and I can import everybody and import them into Teams when I add them, so that way they're automatically in the robotics team and stuff. So it's very slick that way. If you're using the free version, it's a real pain because you got to make sure that you know what email address students used to set it up. And we ran in the other reason with the enterprise is when we did design robots with the free version, but I remember one year the student that was doing the CAD for one particular thing wasn't there and hadn't shared it with anybody, so we couldn't access it. Where with the enterprise, I can access it. Sorry, Sam, what was that?
I didn't realize you were in a different full robot model. I went to like our robot from this year.
Oh, sorry.
Are
you able to find that? I don't want to exit out of that because it wasn't working terribly well. You should be in the team FRC Summer Mentor.
Yeah, I'm here now.
Okay, so so Sam is up there, and so I'm going to double click Sam, and Sam, if you can do something. So right now I can see him maneuvering things around, and I'm following what he's doing basically. So he's zooming in. So this is the beauty, is that you can collaborate. We use Google Meet, but we can collaborate really effectively with doing it this way. So that's how you use follow mode. And this, Sam did an amazing job working with students this year with, he would get them to follow him and he would show them, this is how you design that. And then they would design it. And it allows them to progress at a point that they might not be able to normally. So you can see he's making changes to it. I'm just going to pause right here, Sam. I just want to highlight, can you zoom out a little bit?
Is it frozen or something? Because you should be able to see an intake right now. Oh, bunch or no, sorry,
something's
that's your
frozen.
cursor. Yeah. Click off of me and then click and go back.
So just clicking and then double clicking is initial again. And I think I'm frozen again. That's just great. Oh, there we go. Now I can see. So you can see I've got the hanger bars in there. And so the climber, basically this is just kind of a stopgap to go, okay, when it's fully extended, this is how long it needs to be, so that we can see how it works. And that allows me to work out kind of how things will fit, and will that fit and everything. And this hook, by the way, just our design, our hook was actually longer. The shorter it is, the less contact area you have, the more chance you're going to fall off. And that can be pretty brutal. So everything that's a weird, funky color is something that it's just a placeholder. We're going to fit this in. The blue down at the bottom here, that is basically the mounting for our superstructure. And so that would be replaced with square tubing, but that allows us to work out where the superstructure, and there would be some changes to that based on the whole pattern of the kit of parts doesn't quite line up with that. So there would be some changes, but this was just an example this week. And I blame beautiful summer weather for not getting quite as much done on it as I probably should have. And I'm just going to stop following. The other thing, okay, so that's follow mode. Onshape has a whole bunch of tech tips that show you how to do these different things. The biggest thing is sharing the different documents, and you can share with teams, and that's why I like setting up a team, because then I don't have to remember every student's name. I can just go 4152 CAD team or 4152 full team, or I can share with individuals as well. I've already talked about versioning. Let's see if I can. So I'm going to go back to. So here is a previous version, and you can see I don't have all of the other stuff there. But if I decided I could restore that, which would eliminate everything, or I could return back to my main sketch. So this is really handy because I can look through and see what things we're at different points in time. And if somebody accidentally moves something, then I can actually find the particular point where they moved it and put it back and restore from that point. So I'm just going to return to main. And that's the other thing, is that with versioning, whenever you get to a point where you're like, I want to be able to go back to this if need be, create a version. There's the numbered, but I can change that to a name that's a little more descriptive. And then that way, when I go to my versioning, I can see the changes, and it's like, okay, I want to go back to that. I can just go right to that point, and I can restore it, or I can create a new branch. And this is all versioning stuff that GitHub really made really popular. If you ever have done computer science, that's the idea. Okay, bill of materials. This is where things start getting really handy here. And here's the bill of materials. So with the bill of materials, you get basically when we finish a subsystem, that's where we create a bill of materials. And in here, I have a couple of options. I can add some columns. What I find is the name, the part number, the quantity, the material. I often eliminate, sometimes I have the description, sometimes I don't. The vendor, I like cabining. So that's good. Now, this is where it's really handy, is that I can type in the part number here.
That's not a custom part, so I think you need to find custom
that's
parts.
that's why I can't. Anything gray is not a custom part. So this right here, if I highlight, if I click on that part, that highlights. So that's the drive rail from the kit of parts. That's from the CAD. I can't manipulate that because I didn't create it. So the part number, thankfully, is included in there, which is useful. But here, if I have a part, so there's a hex heavy bolt. If I would go to the Fastenal website, I don't know if that's the number, but I could go to the Fastenal website, go, that's the part number, and get it. And the reason I do this is because anything that is Fastenal, I will then filter my spreadsheet and use it. So things that I create, that's where I put my part number system in. Now I'm in the full robot, so I normally wouldn't do this. Normally I do it for all the subsystems, but basically I would take the different parts and I would just copy and paste and go down to the next one and then the next one. And that way I create one for every single thing. So when I have that, then I take my bill of parts and I can copy it or export it. And I can now add it. So I would have a tab. I'd have a tab for each subsystem and I would paste them in and I've got them. And now that I've got it in here, now I can filter. So anything from Fastenal, and I just phone up Fastenal and I go, okay, this is my part number. I need this many of this. And this is my partner. I need this many of this. That makes it really, really easy for me to order parts. And I do the same stuff. So I do a status and conditional formatting where I'll color code based on if it's been ordered, if we've started manufacturing it, if it's past quality control, all of those different things. So, and this is the beauty, is that we can then sort by part number and just go item 1, item 2, item 3, and it's easy to keep track of what we have, what we've made. And then as a subsystem is done, as it started, we switch to in progress. When it's done and it gets highlighted. So those concepts are really, really crucial. This is a video. I'm not going to play it right now, but it shows you how to create a subsystem, which I've kind of demonstrated already, but that way you've got a reference for it. Oops, all of that. And some other tips that I'm going to quickly go over. So let's start with global variables. Global variables are a new feature. There's a Create Variable Studio. And basically, Part Studio has allowed you to have variables before. In here, this is where I can have a variable and I can set it to a different value and stuff. And I can use this particular variable in different things. And this is Variable Studio I really love because now I can access it. So let's just quickly use one of these to give you an idea. I'm just going to create a part studio. So I'm just going to create a sketch on the front plane. N on my keyboard normalizes my view. And so let's say I've got this shape and I'm going to have a belt that goes on here. So that belt is going to attach to a motor. So I'm going to have a hole somewhere over here and another hole over here. Okay, so I'm designing a belt mechanism. So I'm going to have a motor go from here and another motor from here. And if I go to West Coast Products, they have a belt calculator, which I mentioned earlier. Under resources. And my belt calculator is a GT2 belt, which is a 3mm pitch. And I've got a 12 tooth going to a 24 tooth, and I want it to be about 5 inches. So that tells me there's my options. So I'm going to go for that dimension right there. Now, I'm just going to go back to my Variable Studio and change that value. And what I can do here, yep.
Another good one with the Variable Studio, it had a little description. So if in the belt calculator it told you to use, I didn't see which size belt it was, but if it tells you to use a certain size belt, then put that in the Variable Studio, and it can help you kind of keep track of what belts you're using.
So absolutely. So 105 tooth for 12 to 24. So that's how many teeth, and it's for a 12 tooth pulley to a 24 tooth pulley. So basically, if I go back in that sketch, the dimension tool, the letter D is the dimension tool, and I can click those 2 points, and you'll notice the reason I set it up like this is I can play with my mouse, and I want the center to center distance, which is that distance, not the horizontal and not the vertical. So this is really useful. I can set the center to center, and by typing the number sign, all my variables are there. And I can specify that distance. And there we go. And I can play with the positioning of this. And when I get the positioning that I want, I can lock in that location. And this dimension right there is 1.125. So that's a bearing hole. Now, a little trick, if I add a number sign, I can create a new variable right there. And that's going to be my offset. And I always include an offset, even if I set it for 0. The reason is that if I'm cutting this part, if I cut it on a CNC machine, maybe I need an offset of 0.01 for it to fit perfectly. But if I cut it on the laser, maybe it's 0.005. And this is something that you got to just play with. But by setting that offset, when I was doing some bearing holes for different material, I literally just cut a bunch of holes and then test the bearing and went, oh, that size fits. What's the offset? Perfect. We'll use that when we're making this material. So it's, and because if you 3D print something, then you get a different, so it depends on how you're making it. So there's my sketch. If I extrude this now, that's going to give me a plate with holes in that particular position. And by making that sketch visible, I can now use my feature script. So this little icon, add custom features. If you remember that there's something called add custom features, you can always search for it. And in here, you can search, Julia's feature scripts are the ones that I'm referring to. And there's the most recent version. And you've got all of these different options, and she does this contextless belt. So you just click it and add it, and you can do it. Go through Julia's feature scripts and look at what she's got. So there's so many resources to be able to make things really easily with that. I've already added that. So contextless belts, and in the enterprise, these are my personal ones. These are the ones that I've got for everybody, which I should add the contextless belts for that. So there it is. And so I need to pick my teeth. It was 12 and 24. It was 3 millimeter pitch. And it was that point to that point. And just like that, I love this because it puts it in position. It names it with how many teeth. And that is so useful. So that way you know how that's going to fit together. So now I've got my belt. Yep.
I'll mention, I think MKCAD also has some configurable ones now too. I think they're new, but I ran into them this year. It might just be for chain, but just because someone was asking about chain in the chat.
Oh, I didn't see the chain question. Cool. Yeah, so Sprockets and Chain, there's configurable right there. So
is that just configurable sprockets, or is that chain? Oh no, that is
this
chain.
is chain. Yeah. So if I just insert that, we'll just see. So there's the chain. Now, it doesn't look like chain, but the point is that it's got the geometry that you need. So, and then you can mount it based on those center points, so that you can get things in position. So, yeah. And thinking of West Coast products, I mentioned the belt calculator. They also have a gear calculator and a universal calculator. There is a chain calculator out there. I created my own Python program C# program to do it. Basically, it's geometry. It's fascinating. Global variables, I talked about. Offsets, I talked about. Errors. Let's create an error right now. So a couple things, if you're new to CAD, you'll notice that these lines are black. If I have a line that's blue, that indicates that it is not fully constrained. And I can constrain it. So for example, I can set the angle, and I can set the distance that it's going to be from something. Now, what I want to point out here is if I try to set a distance that is impossible, I'm going to get it red. So anytime you see red indicates that there's an error. In this in a sketch, it's typically means that it's over constrained. I can't have this line be 2 inches this way and then 3 inches from that point. That it just does not work if it's constrained to a 45-degree angle. So it's over constrained. I have to delete one of those to remove that constraint, and whichever one I set will determine. So if I want to constrain that, I need to find another constraint that it will fit. Now this gray indicates that it's based on another dimension. So here's one. Now I've got it fully constrained. This point, I know how far it is from here. I know how far it is from here. I know that my angle is 45 degrees, and I know that that distance is 2 inches. So it's fully constrained, it's black. So that's really handy. If you see red in somewhere, then you know that there is a constraint that doesn't make sense. And when you come across something like that, so I'll purposely break it. The moment you start seeing red, fix it. When you're dealing with a large group project with lots of people, it can get really complicated really fast. And if you have to fix things, then it's a huge issue. So anything that could be the cause of this is highlighted in red. So it's just a matter of going through and deleting the different items till I figure out what it is. Same thing, you saw that when I fastened in the assembly. So if let's just just going to open this up. So here, what I've done is I've purposely deleted one of the points that this fastens to, but basically if you've made a change, it might not be there. Sometimes the easiest way is just to delete it and to see which item is not fully constrained, and then do a new fasten mate. But if you have red, that becomes a big issue. So it's something to keep in mind. Thinking of that, configurations. What a configuration is that it allows me to have different things show up based on different situations. So sorry, I'm just trying to figure out something to configure here. Okay, I'm just going to create a part. No, okay. So configurations are over on the right. There's your configuration panel. And you can click configuration. So we have an elevator here. So maybe we have an extended configuration and a retracted. So those are my two configurations. And what I can do is I can configure those particular things. So there's my climber placeholder. I am going to suppress that. So that's selected. There we go. So in the extended, it's going to be unsuppressed, and retracted, it's going to be suppressed. What that means is that I can go over here and I can select retracted, and just like that, that's gone. And what I would probably do is have a second climber placeholder that's short, so that I click it and it's extended, or vice versa. What I can do though is I can edit. I'm just going to switch to that part studio. And so I'm just having a look at my, so here's my climbing constraint. And basically what I've done is I've set it to be horizontal based on that. So if I show my constraints, you can see there's my constraints. So there's my horizontal. So that point is horizontal to that point. So if I delete that constraint, these are no longer constrained like that. And what I can do is I can set this dimension. So that dimension is perfect. I'm just going to create a variable. There's my extended length. So because I've created it, there's my variable there. Now I'm going to have a configuration here. And again, I'm going to have an extended configuration and a retracted. And my extended, I'm going to take those features and I'm going to select the value. So retracted, I'm going to set it to be 24 inches. So now this configuration, if I look at this, retracted, whoops. I'm going to have a couple other there's an error with sketch 3 because I'm over constrained, of course. So I would need to play with there we go. Not what I wanted to have. I need to redesign this because the problem is that everything else is based on that. That's the length. So that hook is tied into that shape, which is the problem. Anyways, you can see I can set up configurations, but that allows me to have, so you can see I've got a sketch in here, whereas that's, if my robot is pulled up, I can extend and I can fit. So I'm using sketches to kind of make sure I've got my geometry. Now that I've got that, it's not hard to go, okay, this has got to be a piece of square tubing, and designing it's tricky. That's where you have to pay attention to the fundamentals and work those things out. So configurations, really powerful. Sheet metal. Sam, would you mind quickly demonstrating sheet metal?
I can give that a try, yeah.
So how do I stop sharing and get you to share your screen?
Well, I can share my screen, yeah.
Perfect. Yeah, if you can do a sheet metal, just a 90-degree thing, something so that people can see how that works.
All right, I'm gonna do a new part studio for this. Yeah, so there's a bunch of different ways to do sheet metal modeling. The biggest thing is trying to determine which one's best for what you're doing. So I'm just starting a sketch on the front plane here. and I'm just going to draw out the simple bend that I want to create. So I just want to make like, this is going to be a custom piece of L channel maybe. So we're going to make it 4 inches tall, 2 inches wide maybe. And I'm not going to give it any enclosed surfaces. So normally, or what you might think of doing is enclosing it like this so that you get a solid surface that you can extrude. That's not what we're going to do. Instead, we're going to use sheet metal modeling. I think I have to, yeah. I've been using SolidWorks for quite a while here, so I'm switching between them can be a bit hard. Let me show that again. So right here, this is your sheet metal model tool. So if I click that, we have a bunch of different options on how to do this. Convert can be used. It's one that I probably won't recommend using too much, just because if people often get stuck with convert by trying to model something and then make it into a sheet metal model. That's not what the convert tool is meant for. So I wouldn't recommend using that, and it doesn't work that well. Extrude is much better. So what we can do for extrude is we can select where we want the geometry to be. And you can see it's automatically making this bend radius for us. That's configurable through some parameters. We'll get to that. Arcs, you probably won't need to do anything with that, but we can choose how long we want to make it. So maybe we're making 20-inch piece long, or maybe we're just making a little bracket and it's going to be 2 inches long. Symmetric, don't need to worry about that much. And then this is kind of information about the material itself. So maybe it's just going to be made out of 1/8 inch thick aluminum, or 1/8 inch thick anything. And this little arrow right here lets us flip which side of the line we're extruding it on. So you can see it's kind of outside of the line that we had made earlier. But if we flip it to the inside, then it just lets us model it differently depending on our what we're looking for. The bend radius, I'm not going to get into too much on this, but right now I mostly like to just take the thickness of our material and multiply it by, just kind of increase it by 50%. The smallest bend radius you should model for normally would be the thickness of the material. For most material thicknesses, it gets harder to bend radiuses that are smaller than the material thickness. But this kind of depends on the tooling you have to make these parts. So that's where it gets, so if you're just bending it in a vise, it's a bit tricky to get very accurate with this. Unless you have a lot of knowledge on this, just leave bend and the K factor stuff at 0.5. Relief, that's if I'm adding another bend on here, I can make these corners fold up in different ways. So that just lets me make a simple sheet metal part. And the reason that's helpful is right over here, there's this sheet metal view, and I can now view this part flat. So it automatically flattens the part for me. And I could take that and I could export a DXF of the flat patterns that would let me get, so if someone was going to laser cut this for us, we would export a DXF, give it a part name, whatever. Maybe we'd send them a drawing as well. And they can cut it out on whatever machine they have. We can add even more geometry to this. So maybe we want to add a flange to it. select which edge we want to put a flange on. And we can, so this lets us add all sorts of extra geometry to it. We can choose how to align it. So you can see it's aligned up with the outside of the flange is lined up with the inside of the line that we've selected. But if we do it, we can put it on the outside too. So that just depends if I'm mating it up with something that, or depends how you like to model for the most part. How long I want this added flange to be, what angle I want them to be at. I could do 45 degrees, or whatever. And in the previous tool where it talked about relief, that's where I'm getting these little cutouts in the corners. That's just to make the part manufacturable. So there's a lot more you can do with that tool, but that's kind of the basics of it. And we can still edit this model after. So if I want to cut like an angle off of this piece, I'm not going to dimension that right now. I could just remove a nice angle off of that. Maybe someone's going to put a weld down here, make it like a really strong bracket or something. Yeah, that's kind of the basics of the sheet metal tool, I guess.
Thanks, Sam. The sheet metal tool, like, really important to think about, you know, how are you going to build structure? So for us, you know, 90 degree, if you think of just L channel. So that was one thing that we invested some money in is, whoops, am I sharing my screen? There we go. You know, square tubing. So 1x1 square tubing, 1x2 square tubing, L brackets, and then some sheet aluminum and sheet polycarbonate. And you have that, you can do some amazing stuff. But when we're talking about the bending, you know, it doesn't need to be complex. Sam mentioned just using a vise. And with some of the stuff, if you can print off the diagram and just some glue that you can put on the part, that way you can mark where the line is and you can stick it in the vise at that point and just bend it over. It's pretty amazing how accurate you can get using that technique, but don't try to do it during build season. Do it in the off season so that you know that you can do it. And that just makes it a bit easier. The other thing is always think of manufacturing and an assembly when you're designing, and how am I going to physically make this? And Team 2056, if you look at them, they are one of the most successful teams in the world. And if you look at their robots, one of the key things is that they're fairly simple. They're incredibly effective because they try to think about how do we assemble this so that, you know, it's solid, it's not gonna and there's it's incredibly challenging to make a simple, effective design. But the other thing I mentioned earlier on, I'm just gonna demonstrate with this sketch here. Going to make a couple. So I've just added a sketch to this side. 1364 we found is a perfect size for a drill bit for 1032 screws. So
I'll mention 5mm is also a good option if you can get.
Yep. Exactly. So if I have a hole right here, I can create a linear pattern of that hole. And I'm going to have 1 inch apart. So I'm just going to create a grid 3 by 3, and they're all going to be 1 inch apart. And just like that, I've got my holes, and I'm going to extrude them. And a couple tips when you're doing holes like this, always extrude, use the through all feature, because if you, let's say if you go blind, so you're going a set distance and you know the thickness of this part, 1 inch will cover it. Well, if you all of a sudden change your material and now it's 2 inches thick or something, the hole's not going to go all the way through. So using through all allows you to design to really work. So now that we have this part, and if we are in an assembly that uses that part, if I want to insert screws, there's standard content, bolts and screws, socket head screws, number 1032. If I pick 1 inch, because I selected the face, I can click insert, and all of them are going to go in there. And obviously I'd be hard pressed to have a reason why I would do that, but this technique is great for gussets. When you have a lot of machine screws and stuff, and on the flip side, I could do the same thing and insert nuts. But then I have the added bonus of all of those things are now in my bill of materials. And I know exactly there's 9 of them. I had stored the part number for that particular standard content, so I can call Fastenal and I have all my standard stuff that I order, and it just makes it easy. But when you're doing it, you want to really think about, okay, let's say I'm screwing this in. Well, where does my tool go? So maybe it's easier to put the socket on the inside because my Allen key I can fit in there, and I can use a ratchet on the outside to be able to quickly remove the item. So it's about thinking of those things and then designing using that kind of strategy. And it's always think about, like, what tool do I use to assemble this? So here, Allen key, makes sense to put the Allen key where it's hard to reach, and the ratchet on the other side. So I'd have the nuts on this side, because then I can just Allen key in, ratchet, 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 and get everything off really fast. So that kind of strategy of thinking about how it's going to hold together and how you're going to put it together is really, really crucial. So we are now at a point, I'm just going to open up the chat here. I kind of planned for this to be about 2 hours, and I'm 2 hours and 2 minutes, so I'm pretty happy about that. The reason I wanted it to be 2 hours is I wanted to open it up. We've got Sam, we've got myself, we've got Avalon. So if there's a certain thing where you're going like, how do you do this or whatever, then we have the option of being able to do that. And if you look in the chat, early on in the chat, I've got a link to this entire slideshow. I'm going to just paste it in here again. So that way this is available. You're welcome to use it. If you use it with your team or whatever, can you drop me an email so that we can put it in our chairman's presentation? If it's useful for you, that is great. And if it's not useful, if you can give me some feedback on improving this. It's not something that you can cover. Like, there's so much to this. So for the next hour, I'm just going to be on here. And if you want to go, hey, how do you model this or whatever, then we can literally do it right now and be able to play with it. And Sam is much better at CAD than me. So there are some areas where I'll tap him on the shoulder to help me out. So if you have a question, pop it in there. If you're going like it's Friday and it's 8 o'clock and I'm done, no problem at all. I totally get that, but I'm going to stay on here for an hour and model things or practice things based on what people want and what they would be interested in.
And if there's a time later that you want to contact us, like our emails, and both our emails are in the slideshow there, so just feel free to contact us and we can either help you directly or point you in the right direction or whatever works.
Yeah, because especially over the years, we've really learned from other people, and going to district events and championship events and things, it's such a bonus because you learn so much from other people. So we are happy to share, because that's kind of part of our goal is it's a learning thing for us.
Ian, if we don't end up getting, like if people don't ask any questions, then I could show a little more on JVN calculator.
Yeah, why don't you?
I want to make, like, if there's questions, we want to answer questions. So
we'll just play the Jeopardy theme song for a few seconds. Do 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 do. No questions. All right. So Sam's going to show the JVN calculator. This is how we pick what motor and gearing we use for different mechanisms. And we do have a question or a message. So let's. Okay, center of gravity. So
I know I do a lot of this. Do you want me to?
Yeah, do you want to demonstrate the center of gravity? You need to change.
Yeah, you got to stop sharing first.
Yeah, I'm clicking the wrong buttons here. Sorry. Stop share. There it is. Okay, Sam's going to pull it up. Yeah, center of gravity. So while he's pulling it up, deep space, for example, our robot went full tilt in one event, and the robot, the driver hit the brakes, and we ended up tipping our robot, and for the rest of the match we were out of commission. So that was a bit of an issue. And so we're really conscious of center of gravity now, so that the lower it is, the less chance you're going to tip over, but it can also help with hanging and stuff. And I just posted the link again, Stephen. I realized that I had sent it to one individual instead of the whole group, so I fixed that. So, okay, so Sam, you're in there and got the playing field.
Takes a while to load, so yeah. I'm just gonna hang out for a minute. Yeah, so no, and okay. There we go. Okay, now we need to show some stuff because something's missing. Where's our robot? Over here. I realize this is probably an early version of the robot. If you're wondering, this is someone on Chief Delphi made a more simplified version of the field just to make it a little easier to work on computers. Okay, so we kind of got like an early stage of the robot, I guess. And I think when when I was working with students on this, we trying to remember, we set some masses for these. So these are just placeholders for mechanisms that were in the middle of the design. But we wanted to check center of gravity because our climber design was a lot further ahead. So we just made some basic models of what we were like, it's going to kind of look like this, and we think the mechanisms are going to weigh about this much. And then these boxes you see around the outside, those are just, that's what we're using to check our, heights and stuff. So this line right here, that's the max height of the robot, but then this is the max height when we're in the hangar zone. This is the max extension beyond our robot, so we can make sure that nothing's extending too far. Now, if I click on the model itself, so it depends on the orientation. And I'm looking at a side view of the robot. It's just easiest to visualize. But down in the bottom left corner here, or bottom right corner, we have measure and we have display mass properties. So if I click display mass properties, it's going to take a minute here, but it'll give us a guess on the robot weight, which it'll have changed because this is an old model, but it's also going to give us center of mass. And you can use it in different ways. I'll show you a different way to use it after. But in this case, we could use it to check how the robot balances when we're hanging here. But later we can use it to check, like, is our robot likely to be tippy? Okay, so right now we're just going to use it visually. So you can see a little black and white circle here. So that's where the center of mass on the robot is right now. So it's these dimensions aren't useful because they're based after the origin. So they'll be based after this point in the very center of the field. But I'm just worried about where it is visually. So when we were developing our climber this year, we could place it on the bar, and then you put that center of mass point directly below the bar, and that's kind of where that's where the robot will balance. Like if it wasn't rocking back and forth, that's like where it should settle. And it may not be perfect, like your actual robot may be slightly different just because the model's not going to be 100% perfect, but it'll give you pretty close, especially if you're not missing anything too big. Like if you're missing a few bolts or something, it's not going to make a big difference. Yeah, but that's how we use it for like hanging, because I think that's what you asked about. We just line it straight up under the bar, lets us check how we balance out there, and lets us figure out, so that let us figure out that the geometry of our hooks were going to make sense.
I'm just going to mention, Sam had talked about how the X, Y, and Z are based on the origin, and that's why I like moving my drivetrain so it's directly above the origin, so that I can use those values. And the higher up that is, and the more to the side, the more likely you're going to tip. So we've done that before where we use sim motors, and so one of the strategies that we used was just a longer belt so the sim motor could be lower in the robot. We did that for infinite recharge, and it helped take a fairly tall robot and keep a fairly low center of gravity based on where the motors were, because they're so heavy.
Oh yeah, I don't know if you've had this problem, Ian, but there's times when I load up Onshape and it just, the parts are there and they're not hidden, but it won't show anything.
No, while you're loading up, I'm going to share my screen for a second, Sam, because I've got an answer to John's question here. So John's question was tools to see stress on a part. And what I've done is I've gone into applications in the App Store, Now, unfortunately, there's no app that's included directly in Onshape to be able to do that. But I know you've got, I'll let you give your answer in a second, Sam. I know exactly what you're going to say. But there are some free ones, and it's being strategic about if you've got multiple CAD members, then using these later on really helps. The other thing is that there's some certain strategies that help. So if you're going to be 3D printing, really look at, your infill, look at your percentage of your infill. There's certain things you can do to make the part that much more durable. But if you've never done a stress analysis, if you look at this Altair picture, kind of a good idea. So the coloring determines how likely it's going to break. So these red tips or whatever are really likely to break, where the green is not likely to break at all. That's simplifying it considerably, but that's very handy. I find stress analysis really works with 3D printing. And again, there's certain things. So for example, with our climber, I mentioned like we always try to use 1032 bolts. Well, with climbers, because it's supporting so much weight, we use 1/4-inch bolts for climbers so that we have that extra durability. And then we found with their intake, we thought a 16th-inch sidewall for the square tubing would be strong enough, but needs to be 1/8-inch. But if we design it differently so that the intake can freely push back, then there's not as much issue. Anyway, Sam, I know you have an answer for that.
Yeah, scroll down on the page slightly, because we did use it once this year. Actually,
I just did stress, so it might be.
Click on where it says simulation under categories on the left. I get the feeling it was sim scale. I don't remember. We tried it out once this year, but for our climbing hooks, we did do a simulation on it to check that they were strong enough, because they're just made of plastic. So, I mean, realistically, it wasn't that big a deal for the situation. We have enough of them on a robot, but the student wanted to learn to use it. So since I've done some simulation with SolidWorks before, we were like, all right, well, let's give it a try. And we went through it, and we successfully simulated it. So, I mean, we have used it, but I'm not aware of many teams using simulation very often. There's just not that many parts you need to do it on.
Yep. I'm going to just, Stephen's next question, the motion simulator. Stephen, are you talking like an intake, like the motion with it going out and stuff? Is that what you mean by that?
Yes, about the mechanism. Anything about, related to the mechanism.
Sam, do you want to field that? Because you've used that.
Yeah, so there's not, I got to share my screen though.
Yeah.
So there's not there's not something called motion simulation. But where Ian was showing you about fasten mates earlier, there's other types of mates you can use to make joints flexible and stuff. So one of the ones I'll show here, if anyone's wondering, we do a lot of configurations on stuff to make everything, give us options, and it just lets us do a lot of stuff quickly without having to, and these big models are really slow sometimes, but right here I have all these rotation points. They're not fixed. They're flexible in some way, and it's letting me click and drag it around. see how the motion works. I don't have any limits right now, so you can go too far, but yeah, this might be kind of what you're looking for.
Yeah, that's great. But besides that, does it allow or detect the dynamic interference?
I don't know of any team going that far. I mean, I know in SolidWorks you can do some dynamic simulation stuff,
Yeah.
but like it's not something I've even messed with. So
I see. Okay, but that looks great. Okay, thank you. Yeah.
Back to the center of gravity quickly. So our robot's right at the origin here. It's centered on all the planes. And then I have a configuration set up for center of gravity here. So that just includes the bumpers and the battery and stuff so that it gets the proper weight for everything. And this might take another minute here, but because the origin's right at the center here, the dimensions we get will be like pretty close to on point. And I know these are pretty accurate because the mass of this is within a few pounds of what our actual robot ended up being. So we're pretty close to, although I bet it's going to be different right now because there's 2 intakes in the model, so it'll be really heavy. But we'll see. Was there something else you were going to say, Ian?
I'm pulling something together to explain the motion question, just so people can see how to do it pretty easily. So I'm just creating a quick sketch here to demonstrate.
Okay.
So
there we go. Yeah, so our weight's up a bit, and that's because we have a few things unsuppressed here that are adding a whole bunch of weight. That's yeah, don't need to worry too much about that right now. Yeah, center of mass. So we can see, so this is the triad, the blue, yellow, and red lines there. That's like a little triad that gives you different directions. Anyway, so in the Z direction, which is up in this case, we can see our center of mass is 8 inches up here. And it's probably, I know that for the actual robot, it should be up a little bit more and back a little bit. So I think, but, and that little visual indicator also shows you, but it's kind of a good way to look and see how tippy is my robot. If your mass is center of gravity is like way up here, your robot's definitely going to be tippy. But if your center of gravity is way down in your chassis, then you probably have a really low center of gravity and you'll have a lot harder time flipping your robot over. The other thing to consider with if your robot's going to be tippy or something is wheelbase. So some teams have been making smaller wheelbases this year, slightly more compact robots. But unfortunately, it means it's a little bit easier to tip because it's like a big lever arm, like it's getting into torque calculations and stuff, but just shorter wheelbase will generally be easier to tip, right? So, and it even like 1114 has I believe they have a slightly smaller wheelbase than normal, and at Worlds they hit a little beam and tipped over, unfortunately, and you know, if they had a full-size robot, maybe they wouldn't have been quite as tippy. So not saying that you shouldn't go, like I'm not arguing against small robots, but it's a factor to consider. So
I'm just going to throw in, so here with talking about motion, so most of the time we try to use the fasten mate, but as Sam mentioned, there's really good reasons to use other mates. So the Revolut Mate, for example, allows me to take my 2 points, whoops, and I can revolve them. So right now, let's say I can go from 0 to 180. I can actually play that and I can see what that looks like. That looks like 360 instead of 180, but so you can see, oops, go back into that. So I can see the range of motion, and so it's like, okay, I want to make sure I set a hard stop there or whatever. Then I can do it, and this is obviously not constrained. So if I just fix that, now I can see it going the way I want. So yeah, so these different mates, so the Revolut, it revolves, you have a slider mate. So if you're doing a pneumatic cylinder, that could be really handy. A planar mate can be as useful if you're trying to lay things out, like your electrical board or something like that. And some of these, like if you're modeling the intake, sometimes you need to be able to use the cylinder to make things work, those kind of mates. So we don't tend to use those very frequently, but when you do want to model motion, yeah, it's very, very useful. And as Sam said, once you have the item in place, you should be able to click it and drag it. But that's where those limits come into place. So with the configuration, you can configure different things so that you can see it in the 0 position, in the 45 position, or free where you can click and drag it. So Stephen, does that answer your motion simulator question?
Yes, very nice. Thank you.
Question for you, Ian, here, I think, about BOM.
BOM, possible to easily determine how much material you will need. Yeah, that's a great question, and short answer is no, but there's tricks. And I'm just going to demonstrate a quick so let's so a couple things that I'm just going to demonstrate creating some mechanism. So let's say I've got 6 inches by 6 inches. It's extruded. I'm dealing with 1/4 inch material. And I'm going to create another sketch. So I got something going on here. Sometimes it's quicker to just undo. Okay, so let's say I've got a thing like this. Oops. So this is obviously very, very simple. You got two pieces of material joined together. If I'm doing them all in one part studio, the bonus is that I can go into properties and I can select 1/4 inch thick polycarbonate for the name. And all of them are 1/4 inch thick polycarbonate, just like that. And I can go, okay, so that's 8 inches by 6 inches. So I can quickly go in and rename everything. And I do use this strategy, so it does help. But the other tool that I want to mention was the auto layout. So if everything's in one thing, and I use my auto layout tool, our CNC router is 24 inches by 36. So I always kind of deal with sheets that dimension or whatever. But the beauty is that I can have that, and I'm just going to go back. So let's make some changes here. So instead of 6, 22 by 22. Okay, so now if I'm looking at this, that's the extrude. The auto layout, here's the beauty, is it's separating them because it can't fit both of them onto my bed of my sheets. So I know right off the bat, I'm going to need 2 sheets of 24 by 36 polycarbonate to make this. And that auto layout, I can just right click and suppress it so that I only use it when I'm kind of going, okay, how much material do I need for this particular thing? And then I can work it out. And then if I create an assembly based on this, I can put in the description, need X number of sheets for this and stuff. So there's some workarounds. It's not great with raw materials that way, but I have used that technique and I found it works pretty well. Like I'm building a structure right now, and so it's like, okay, square footage and stuff, but using that in the names can really make it easy to do that. So I hope that helps, John.
I got a little thing on stress to show, Ian.
Yep, not a problem. I'll stop sharing.
Okay, so when you're similar to the simulation question earlier, when you're thinking about how strong is a part, generally the weakest points are going to be hard corners. So those are stress concentrators. So like all the stress will be built up in right on that sharp point. And those sharp points are likely where you'll see it fail. So maybe it's here, there, over here. If I had some holes here to mount it, you might find that the crack went from a hole straight to a corner. So the problem here, so there's things we can do to make these corners stronger. So right here we have the fillet tool. And this lets you round corners to whatever radius you want. So I can select a corner here and I can give it a radius, something really big, something small, whatever. And it'll give a nice rounded corner here. So what happens now is the stress, instead of being concentrated on one point, it's distributed over this whole curve. So it there's a lot less stress at any one point at this corner because it's distributed over the whatever force is on it is distributed over the whole area. So even if there's not a lot of, even if all you have is a bolt hole here, having a rounded corner on the outside or something might make your part stronger. You're actually removing material and making your part stronger at the same time. So like if you look at our robot, all our corners are using, so some of it may be excessive or whatever, but every little corner has rounded corners in it because it's easier for cutting and it's easier for and it reduces the amount of stress on the part without really adding much weight or without adding or removing much weight. So that's just something to consider when you're making all these parts. Same goes for 3D printed parts. I don't have a great example of a heavy duty 3D printed part right now, but yeah, I mean something like this hood here. Okay, so that hood is a big 3D printed part. And the top here, instead of having a solid edge, it's rounded. So it might seal that edge a little better, make it less likely to crack. Same at the back here and stuff, all these little rounded edges. Just goes to help make the part stronger. So
I'm going to jump in there with the 3D printing part. Often it's beneficial to break a 3D printed part into separate parts. So if you think about how the 3D printer works, it's basically putting down layers and layers of plastic. So if you have something like the hood there, it might make sense to print the hood on its side and then have 3D printed spacers, which I think we've got there, so that way it's 3D printing a solid part, and then the spacers are solid parts by themselves. But by using that kind of technique, you can actually make some really complex shapes, and they're stronger than if they had been 3D printed by themselves, because if they're 3D printed and you've got this gap, well, it's got support material, it's not quite as strong. So if you can remove that and have it a solid, that just gives it that extra strength.
And a little part like this, I mean, this has got infill in it. So this part is a, I don't know what info we were using. It's pretty low actually, but you know, it's got like, this part's got like 27 or 30% infill. So it's a whole bunch of the inside of this piece is actually hollow. So this thing weighs almost nothing. Like you can see how much it weighs right now if it was solid. So if it was solid, it'd weigh 1.3 pounds. But right now it weighs like a third of a pound or something. I don't know. Now on its own, it wouldn't be strong enough. So what we have here is we have these little steel rods going through. So it's just steel rods with threads on the end. And that just gives it a lot. That's what's giving the hood all its strength while not adding a whole lot of weight or anything. It lets us get this nice smooth surface for the ball to roll on, but also relatively cheap and lightweight and stuff. So I was going to talk about JVN.
Yeah, so let's do some JVN stuff.
Okay, so we don't have long, so I'm not going to get into like a lot into the physics of it. So we don't know a lot of physics. I mean, physics helps you understand this a lot better, but we'll just go through it for now. It's not necessary. Yeah, so we got a whole bunch of different calculators here. We've messed with them a little bit just because we've been trying to add some of our own features and stuff. So, well, that's mostly me doing that, but I mess around with this every once in a while. So anyway, we got on all these pages, we got these little drop downs for motors. We can select based on whatever motor we've got. Right now I'm in a drivetrain, so I'm designing a drivetrain. Maybe we're powering it with sim motors. And if we're using a standard tank drive that we're used to, like a CAD parts drive, we're going to have 2 gearboxes. So there's a gearbox on the left, gearbox on the right, and we're going to have 2 motors on each gearbox. That's the most common setup. We can change this. So if you had like a really powerful robot that uses 3 motors or something, we can just do 3 motors for each gearbox. But we'll stick to CAD parts here. Weight of the robot. So this is just, you're assuming your robot's going to weigh 154 pounds. That would be a max weight robot with batteries and bumpers. That's kind of what you're likely to hit for weight. Your wheel diameter. So the CAD parts uses 6-inch wheels, and wheel coefficient. Some manufacturers have that listed. It's not, I wouldn't get too worked up about it, especially if you don't know what it is. So we'll just leave that at 1. And then we got our actual gear ratios here. So inside the gearbox, what we've got is on the sim motor itself, there's a 14-tooth gear, and that's driving a 50-tooth gear, which is then driving a 16-tooth gear and driving a 48-tooth gear, which is then driving the output, the actual axle that is spinning the wheel. So inputting these gears here, there's our gear ratio right there, 10.71. Just gonna delete those. 10.71 to 1. So that's kind of the gearbox ratio. And you get drivetrain free speed and drivetrain adjusted speed. So free speeds was often listed by people. So this is in theory how fast your drivetrain will go, but this would be without any weight. So if you're just lifting it up in the air, that's how fast the wheels would be, the speed of the surface of the wheels would be going. But then over here we have adjusted speeds. So this is trying to account for the weight and coefficient, or yeah, this is mostly just taking so it's just taking account of the weight of the drivetrain to figure out how fast you should be going. I found this to be pretty accurate. Like, we do tend to be roughly around this adjusted speed, so it works for the most part if you want to know how fast you can go. And then pushing current drop per motor. So this is it's tough. It's not always accurate, but it lets you determine. So if you were how much amperage your motors would be drawing. I'm trying to figure out how it would. Yeah, I'm not going to worry about it for a drivetrain. Don't get into this too much for drivetrain. It's kind of confusing. But then we can also use it for other mechanisms. So how we'd use the linear mechanism one for designing all our elevators every year. So any year we've designed an elevator. So this year we're using Neo motors, and we have 2. Technically, we have 2 gearboxes, but it works out to the same thing. If it was 2 gearboxes with 1 motor each, or two motors and 1 gearbox, it's the same thing. Because they're working as if it's one system anyway. But we were using 2 motors. Leave gearbox efficiency where it is. Travel distance, it's maybe a little less important. If you want to figure out how fast it'll take, it's nice, but it's not super necessary. Applied load, that's how much it's lifting in this case. So if you were trying to raise an elevator up holding a ball, you'd have to include all the components that it's lifting. So all the elevator components and whatnot. In our case, this year, we're lifting the robot in the air, so we're including everything on the robot that has to go up. So bumpers, battery, structure, shooter, everything. The only thing we wouldn't include is, in our case, is these pieces, because they aren't being lifted. They're the parts that are pulling the rest of the robot up, so they'd already be up there. But you may choose to include those anyway, because it gives you a bit of factor of safety. Like it makes sure you're within the limits of the motor, of the motors. And then the weight's also really high, because in this case, we have these constant force springs. So they actually add more weight when we're lifting, but they help simplify other mechanisms. So we include that in there, but all the weight, that whatever force it's got to react against, that's how much weight you put here. You can mess around with gear ratios a bit to figure out what works for you. So in our case, for our elevator this year, we're using a 10-tooth pinion on the motor or gear and a 68-tooth gear. I can show that down here. So that's these two gears right here. And that gear is driving an axle, which is driving a little the intake. It's in the way. So it's driving a little winch spindle in here, which is driving the elevator. So then we can put right here the diameter of that pulley. So what the rope or chain, if you were using chain, you could use the diameter of the sprocket. If you're using rope, you can use the diameter of the winch spool. So if I measure it right now, this winch spool is 7.87 inches in diameter. So I can then just input that right there, 0.787 inches. And it's going to calculate how fast it takes to travel this distance. If there was no load on it, so if it was moving with no weight, that's how fast it should be. And if it's moving underweight, that's how fast it should be. And it's also going to take a guess at how much current your motor pulls. Now, your breakers have the max breaker you can put on your robot as a 40 amp breaker. So it's good to stay under the limit of whatever breaker you're on, obviously. You'll probably run into issues if you're over that. So what it's saying here, max current draw per motor, if it's loaded, or the current draw per motor if it's loaded. So under this load, each motor is going to be pulling 33.67 amps, which is under our 40 amp limit. And give some margin of safety. So don't go to 39 just because your breakers are 40. So we're giving ourselves some margin of limit. And we've used this for a number of years too. So we have some experience of kind of what the limits are and how much we can push that. But that's how we calculate, like that's how our climbs were, like when our climbs were working, that's why they were really fast, was because we use this to calculate it and to really push the limits of it as fast as we could. We didn't just put a really big gearbox on it. We put the smallest possible gearbox on it, while being within some sort of safety margin. So if you're using that, again, just if you're using this, select the motors you want to use. You can switch around and try different motors if you want. How many motors you want to use, how much load it's got to lift, travel distance, the pulley diameter you're using. Messing with this will also make a difference. So like if I make this smaller, obviously it's going to go slower, but it's going to take less current as well. Mess around with gears. Again, this is where you can try maybe a 12, maybe a 10. Maybe if I use an 11, it'll be a little bit quicker, but it's going to pull more power. So you can mess around with gear ratios here, and it'll give you kind of a guess, and it lets you design your mechanisms around these calculations and try and get a sense for what's like a good gear ratio to use. I'm not going to get into it now, but there's ones for rotary as well. So if you had like an arm rotating with a motor, you can use that. I don't think we really use the intake mechanism that much.
With intakes, a rule of thumb is to kind of make sure that your intake's going twice the speed of your drivetrain.
And that's not RPM, that's the surface speed. So
Yep.
like if you converted the speed of the wheel to like, if it was driving on the ground, how fast would that be?
Yeah, because basically if you're driving forward, it's just going to bounce off unless it's going faster. So we have about 10 more minutes. Any last questions? Well, thank you all. Thanks, Sam, for helping with this. And yeah, during the season and the fall and stuff, please don't hesitate to give us a shout if you need some advice or need some help. One thing that we love about First Robotics, and especially the Canadian area, is that teams are so willing to help each other, and it makes a big difference for everybody.
So thank you again to everyone, and in particular the team members of Team 4152. That's Ian and Sam and Avalon. It was a really great session, and really looking forward to seeing it posted myself, even though I'm going to post it. I just had trouble hearing here in the intersection area. It was really great what I was seeing though, and I'm looking forward to more sessions in upcoming weeks. So again, thank you very much to Team 4152.
And I have a quick question for you, William. How many Tim Hortons coffees did you buy today since you were camped out there?
Because there's no Interact working, so none. I think Interact's off as well. Didn't want to break my cache, so I'm just anyway. I had enough coffee at home.
Perfect.
So thank you so much again. That was really great. I'm very glad that most people were able to make it on despite the outage. So that's good.
Well, have a great weekend, everyone.
Have a great evening, and thank you again. We'll post it as soon as we can get our internet service back.